Okay, welcome my dear students to this next online session on industrial metallurgy. This is session number 25. These are the different contents that we'll cover in this session. Particularly, we'll talk about an introduction of the type 2 binary alloy systems and why do they get their name eutectic. So why are they referred to as eutectics? We'll also try to see. Uh, for an example to illustrate the type 2 binary alloys, the example of bismuth cadmium binary alloys would be taken. So let's first of all define as to what are type 2 binary alloys. You see, binary alloys are alloys in which the two constituent elements that you have taken to form the alloy show 100%, that is complete liquid solubility, but they show zero solid solubility. That means binary alloys in which the two constituent elements are such that when they are taken in the liquid state, when they are in the molten state together, they may have been taken in any weight ratio, they will always form a homogeneous liquid solution. So the two constituent elements, when in the liquid state, taken at any weight ratio, if they form homogeneous liquid solution, that is single phase liquid, then they are said to be having 100% liquid solubility, and so do these type 2 systems have. But when solidification takes place, they crystallize as pure elements. They do not form mixed crystals. That is what is meant by 0% solid solubility. And if you discuss, if you remember, we had discussed that for formation of solid solutions, particularly the substitutional solid solutions, Hume Rothery had given some rules, and these were 4 rules. And for formation of a good substitutional solid solution, these rules must be obeyed. Now, if these type 2 systems are not ready to form a solid solution with each other, mixed crystals with each other, are showing 0% solid solubility, that means that they are disobeying most of these Hume Rothery rules, right? Then these type 2 binary alloy systems are also called eutectic systems or eutectics. Why? You see, the term eutectic again comes from Greek language. The word in Greek is eutectos, and this word or term eutectos means anything which is capable of getting melted very easily. So if you heat something and it gets very easily melted, it's a eutectos. So there are 2 reasons as to why type 2 systems and thereafter also type 3 systems are referred to as eutectic systems. Point number 1, when you take any type 2 alloy system, for example, you take bismuth cadmium. Bismuth cadmium alloy system is an example of type 2 binary alloys. Now, you can form infinite number of compositions by taking bismuth and cadmium in different proportions, and you can form infinite number of different alloys out of them. In this bismuth cadmium alloy series, or in any type 2 alloy series, mandatorily, necessarily, you will find one composition which would not melt like alloys. See, alloys generally melt over a range of temperature. There would be a solidus temperature where their melting would start, and there would be a liquidus temperature at a higher temperature where their melting would get completed. And alloys most generally would always have a solidification temperature range. They will not melt or freeze at a single temperature as the metals do. But type 2 systems will always have a composition which, unlike the alloys, will melt or solidify at a single temperature. So it would not have a freezing range or a melting range, rather it would have a sharp melting point or a freezing point like the pure metal systems. And this composition, this unique composition, is referred to as eutectic composition because it melts easily, right? So for this reason, type 2 systems are called eutectic systems, because they always contain a composition called the eutectic composition. Point number 2, there is a reaction which we'll cover after some sessions called the eutectic reaction. Whenever you are talking about any type 2 system, some of the alloys of that type 2 system, or even all alloys of the type 2 system in some cases, will definitely show this peculiar reaction called the eutectic reaction. So students, because of these two reasons, eutectic systems name is given to type 2 systems and even to type 3 systems. Okay, then as I said, we are taking the example of bismuth and cadmium to explain the type 2 systems to you. Now let us see, because a while ago I said that most of the Hume-Rowe 3 conditions are not met by material systems which belong to type 2 systems. And what were the Hume-Rowe 3 rules? The Hume-Rowe 3 rules, the first rule was crystal structure. The crystal structure should be similar. It should not be very, very dissimilar. But they disobey this rule. Why? The bismuth has got a very, very complicated crystal structure, whereas cadmium has got a very, very simple crystal structure, HCP. Then in one of the Hume-Rowe 3 rules, we had said that chemical affinity, the two elements which are trying to form a substitutional solid solution, must not have chemical affinity between them. It should not happen that one of the elements is very electropositive, the other is very, very electronegative. But same happens in case of bismuth and cadmium. Bismuth is a less metallic element, whereas cadmium is a highly, highly metallic element. So these two elements, in a sense, have affinity between them, which is not a good thing for the formation of solid solution. But the affinity is not that great that they can form a compound, a conventional compound, because if the affinity had been great, conditions would have been conducive for the formation of bonding. They would have formed a covalent bond or an ionic bond. So they are landing in no man's land. They are not able to form a conventional compound. They are not even able to form a good solid solution. This is type 2 systems. Then if you talk about even about their mechanical properties, bismuth is a highly brittle material, whereas cadmium is highly, highly metallic, very ductile, very malleable. So because of these differences, they do not obey most of the Hume-Rowe 3 rules, and as such, they are not able to form mixed crystals between them, and thus they get into this type 2 material system slot. So they are material system which show complete liquid solubility. That is something strange, that in the liquid state, in the molten state, they can mix and form a homogeneous liquid solution irrespective of the fact that in what weight ratio they have been taken. But when it comes to remaining mixed with each other in the solid state, they behave very, very miserable. Okay, so I think this also I have covered, and we'll take up the equilibrium diagram of type 2 systems in the next session. Thank you for watching.